My name's Hugh James. I'm a science communicator. I take complex science principles and make them understandable for everyone. My specialism is in astronomy and space science, and I'm a fellow of the Royal Astronomical Society. To understand black holes, you really got to understand a little bit about the universe itself. The general theory of relativity tells us that the universe isn't static or rigid, like the surface of a table. It's more like the mattress on your bed. It's flexible. And then things like stars and, at an extreme, black holes, they change the space around them. Black holes are basically objects in the universe that nothing can escape from, not even light. They're normally dead stars that have been shrunk down, so you have lots and lots of mass in a very, very small space. Take the sun, for example. If we shrunk that down to the size of a ping pong ball, then we'd have a black hole. Stephen Hawking was a visionary when it came to black holes. He was on a quest to find a theory of everything, and his mission to find out what happened at the beginning of the universe brought him right face to face with these things we call black holes. His work saw him making some amazing breakthroughs in black hole research. His greatest feat was partially joining the two big theories in cosmology, quantum mechanics and general relativity. Well, black holes will be difficult to see even if they weren't black. Some of them can be around 20 miles across, and we're looking for them in a massive universe. No light can come from them, but we can have a look at the effects that they have on the universe around them. When two of these black holes come close to one another, they change the space around them, creating waves that travel across the universe at the speed of light. It may well be possible to hear these black holes if we can find these waves and turn them into sound waves. A group of scientists at Cardiff University have been having some fun with these waves and turned them into ringtones for your mobile phone. Everyone wants to know what's going on inside a black hole, but seeing inside them and proving what's going on are two very different things. Gravitational wave astronomy can help us create simulations to find out what's going on at the basic level. Do we really need to know that black holes exist? How does that matter to us on Earth? Science is full of questions like that. Does it really matter to me? For me, the pursuit of knowledge is a worthy cause by itself. However, we never really know when this knowledge is going to be useful. Take general relativity, for example. Back in the early 1900s, we could never have predicted that Einstein's theories would be used to influence satellite navigation. But now, without knowing those minute time differences, satellite navigation would be miles off every single day. For me, Hawking's work with black holes would go down as some of the most groundbreaking scientific discoveries in human history, and his story of overcoming adversity, legendary. Obviously, there's been other great scientific discoveries, like penicillin, for example, but those two, black holes and penicillin, are very, very different. Penicillin is a very practical discovery. It helps humans, but doesn't help us understand the universe. Black holes, however, help us understand how we fit into the bigger picture, ultimately leading to a theory of everything. I've always been a big fan of exploration and discovery. The explorers of today are definitely the scientists in both body and in mind. One of the best discoveries for me would be a planet orbiting another star that we can live on.